let's now have a little talk about web applications. We use web applications all the time for so many purposes. It's important to understand architecture and the vulnerability stack for web applications. So let's have a look at that. And for web applications, it's the interface between the web server, the information, the backend database, and the user. And hopefully, the developers have used security policies. If they haven't, or there are poor policies, they're going to have vulnerabilities to attacks like cross-site scripting and SQL injection and session hijacking and many others. So we need to make sure we're ready for that. This is just a look at how web applications work. Now, for a website or a web app, it's usually implemented on what we call an N-tier architecture, which we'll look at in just a moment. But let's just look and see what happens when this user goes to a website. Now, when we use the term go to a website, in actuality, we are either typing in the URL or clicking on a link, and we are making a request to the web server for us to download the website. So whether it's on your phone, whether it's on your tablet, or whether it is on your PC, you are downloading the website. And it really depends on some variables, like how much storage you have and so on. But you're downloading that website. Another thing that I want you to have a look at, especially for hacking web applications, before we talk about how it works in specific, is this right over here. See right on the top of the screen, we have the URL. Let's talk about what this URL means. A lot of people don't think about what a URL means. So on the far left side, what we have is the protocol. We're saying, what protocol do I use to access the resource? So the protocol in this case is HTTP. There are many other protocols that can be used to access resources. Not all of them, though, would be web resources. Like HTTP and HTTPS are web resources, but if I put FTP, that's not web, right? It doesn't have markup language and tags and so on. So HTTP is the protocol that I want to use. All right, so if I'm using that protocol, where am I getting the resource? All right, so the resource is on the top level domain of com and a subdomain of certified hacker. So that secondary level domain or subdomain is one that you or I could buy. So for instance, I could go to GoDaddy right now or domains.com and buy the domain Kevin King bought this domain.com. I know that that domain has not been taken yet. And I can use that as part of the domain. Now, as you notice, we stopped there, just certifiedhacker.com. Now, in this case, since a document was not specified after the slash, there wasn't anything that said index.html or document.htm or anything like that. So no document is specified. So what happens is the web server will serve up the default document in that document folder. And so the default document is often like an index.html. All right, so another very important aspect of this is the next part of this URL, that question mark. That question mark is the dividing line between the protocol that we're going to be using and the location of the document that's going to be served according to that protocol, right? We've located the document, we are able to serve it up, and then to the right of that question mark, we have what are called parameters. We have an ID, we have whether it's printable or not, right? So one of the attacks is where you can take those parameters, the 6329 or the Y for print, and modify it. So I can modify the parameter from ID 6329 to 6330. And let's say that the print had been set to N, and I could set the print to Y. It might take me to a completely different person's information and allow me to print it. That's called parameter tampering, and all that takes place after the question mark. Before the question mark is document location and protocol. After the question mark are parameters that when you hit enter, are sent back to the web server for processing, right? So remember, everything's on your local system, but when you hit enter, it gets sent through the internet, through any firewalls, to the web server. The web server may then contact a web application server, and that web application server may say, hey, database server, there is an ID of 6329 that's specified. Database server, can you please look that up? The database server says, okay, I have a query. The query is select everything, select star, from a table. What's the table called? News. All right, here's the news table where ID equals 6329. All right, here's the ID. What do I find there? I find tech and CNN. All right, let's feed that information back. There you go, web application server. This is what I found for ID 6329er. All right, web application server, let's create a page to send to the user and squirt that page over to the user through the firewall all the way around the routers of the internet, little BGP action there, and boom, the page gets downloaded. From the perspective of the web server, it's uploaded, but from the perspective of the user, it's downloaded, and it appears with the appropriate information. So like I was saying, a web app is usually an N-tier application. N meaning as many numbers, right? So this is a 3-tier application. Lower tier, tier number 3, is the database. Tier number 2 is the business layer, and tier number 1 is the web layer. In tier number 1 is where the web pages are created or used to upload to a browser. Tier number 2 is where business logic and calculations take place. And then tier number 3 is where you have your database, where you have a Microsoft SQL Server, Oracle database server, and others. So just to give you a quick example, I always use this example because it's very simple to illustrate. But let's say that I'm on a browser. I type in www.myreallycoolbank.com, and I go to my bank, login. A page is sent to me with all the basics for somebody who is authenticated to the bank with specifics for my account. So in my page, I click on transfer. So when I click on transfer, it sends a request back to the web server, and it finds a page that has transfer information on it, and then it sends that back to my device. I download that page into my device. Now in the transfer page, there's a window for checking or savings. So I put $100 in the checking, and I tell it to transfer it to savings. So once I hit that button, then that information is submitted back to the web server. And now we go to the logic layer, the business layer, where somebody wrote Java or C# or Ruby or PHP or Python or all of these to get my business logic running. And then the business logic will say, okay, let's make sure that the Kevin King login is secure and actually has a savings account. All right, let's check database. Savings account, yes, no, yes. All right, does he have a checking account? Checking account, yes, no, yes. All right, good. Is there $100 available? $100 available, yes, no. Yes, there's $100 available. Okay, is there a place to put the $100? Yes, there is. It does all these kind of checkings in the background. And then it says, all right, database, decrement checking by $100 and increment savings by $100, and then give me your results. And it does that, and then it creates a new page, and then that page is sent to my browser, and it says, congratulations, you have transferred $100 from checking to saving. Is there any other thing you want to do? So that's what an N-tier application looks like, with the business logic and the web services and the database layer at the bottom. All right, it's good to know how some of these things work. Now let's look at some web services. Now, beyond just the tiered web delivery system, there are some more complicated services and applications that are deployed over the internet. Remember, we're not just talking about web pages. We're talking about complicated applications with protocols like SOAP and WSDL, UDDI, REST, etc. And what do? They help with service delivery to find and publish and bind requests to service providers to make sure that those requests get fulfilled. And there are descriptions of all the services available to web servers available in a service registry. And I wish we had time to go into some of these services. These are things that you learn a lot about when you are doing web application programming. We get to talk a little bit about it, though, looking at some of the top level definitions for SOAP and REST in particular. SOAP is based on XML. If you've never seen XML, right now, go to a search window in DuckDuckGo or Google and type in XML document. And then go to images, and you'll see how XML looks. It's a markup language. It's actually made to be fast and machine readable, but it's also pretty human readable too. You can see that if you go to images and look at XML documents. But what this does is it transfers data between the service provider and the requester. So you can create all these very quick SOAP requests in moving data between those two aspects of your web application. There's also the idea of RESTful web services, and this is just basically a set of constraints underlying the way HTTP is implemented to help improve performance. And there's literally days worth of information to talk about each of these, and there are so many different versions and then replacements for these, but this is not the class for that. If you want to know that, go into a web application programming class. All right, so with web applications, it was bad enough with web servers. Look right over here, web servers, all the way at layer 5. But with web applications, not only do we have third-party components that we purchase commercially or that we use and implement through open source, but we have the custom applications written with potential business flaws and potential technical vulnerabilities. Look at all of these stacks that we have to protect in order to keep our web applications safe. So there's a lot to think about when you're defending web applications.